Hello everyone. So here we shall solve some more KCET previous year questions on the chapter matrices and determinants. So in the previous part of this on this chapter, we had solved till the question number 32. So in this video on matrices and determinants, we shall start from the question number 33. So if you're unable to understand any steps of the solutions or any other doubts if you have, then please write us in the comment section. And in 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 any other chapter of maths, if you feel more difficulty, then please write the name of that chapter in the comments section. Then we shall give more priority on it and solve more and more questions on that chapter. Also, the homeworks on every chapter will be uploaded in the Sapience education application. So please install our Sapience education application, whose link has been provided in the description. So here it is told that if the matrix A is alpha 2 alpha, then and the determinant of A cube, that is equal to 125, then alpha equal to how much? So now the determinant of A cube, we can say that is equal to determinant of A whole cube, that is equal to 125. So it means that determinant of A, that is equal to 5. So now if we find the determinant of A, that will be equal to alpha square minus 4. Alpha square minus 4, that is equal to 5. Alpha square is equal to 9. Alpha will be equal to plus or minus 3. Option C is the correct answer. Then in question number 34, it is told if A is this and B is this, A is the determinant of this, B is the determinant of x1, 1x, then dA by dx is how much? Now therefore the matrix A, it means the determinant A, that is equal to x into x square minus 1 into x minus 1 and plus 1 into 1 minus x. This will be equal to x cube minus x plus 1 minus x. So this will be equal to x cube minus 3x plus 2. Now therefore dA by dx, that will be equal to 3x square minus 3. That is equal to 3 into x square minus 1. Now b is equal to x square minus 1. Therefore dA by dx is 3b. So option B is the correct answer. Then in question number 35, it is told if the determinant of the adjoint of a real matrix 3, the determinant of the adjoint of a real matrix order 3 is 25, then the determinant of the inverse of the matrix. So determinant of the inverse, that is given as 1 by determinant of A. Now the determinant of adjoint of A, that is given as A raised to n minus 1, where n is the order of the matrix. Now here n is 3, therefore this is equal to A square, since n is equal to 3. So therefore for this determinant of A whole raised to n minus 1, this the determinant of A whole square. So therefore determinant of A square, that is equal to 25. So therefore the determinant of A, that will be plus or minus 5. So therefore the determinant of the inverse, that will be equal to 1 by plus or minus 5, that is plus or minus by 5 is 0.2. So option D is the correct answer. Then question number 36, it is told if the matrix 2, 3, 5, minus 1, that is equal to A plus B, where A is the symmetric matrix and B is the skew symmetric matrix, then B is. So we know that any matrix suppose C, any matrix C can be written as the sum of symmetric and skew symmetric matrix. C can be written as C plus C transpose by 2 plus C minus C transpose by 2 minus C transpose by 2. So this will be the symmetric matrix and this will be skew symmetric matrix. Now therefore let let us say the matrix C is 2 3 5 minus 1, and this implies C transpose will be equal to 2 5 3 minus 1. Now therefore half of C plus C transpose, this is the symmetric matrix which is A. Therefore A will be equal to half of this 2 plus this, so 2 plus 2 4, 3 plus 5 8 plus 5 8, this is minus 2, so it will be 2 4 4 minus 1. And the matrix B, that is skew symmetric, that is half into C minus C transpose, so that is half into C, that is 2 3 5 1, that minus C transpose, which is 2 5 3 minus 1. So this will be half of, so 2 minus 2, that is 0, 3 minus 5, that is minus 2, but then 5 minus 3, that is 2, minus 1 plus 1, that is 0. This will be 0 minus 1 1 0. This is the matrix B. Option D is the correct answer. So then here it is told, if the matrix A is a 3 cross 4 matrix, matrix B is a matrix such that A transpose B, that A transpose B and BA transpose are both defined. They are both defined. So B is of the type. So let's say B is of the order M cross N. So A transpose, so from here we can say A transpose will be of the order 4 cross 3. So A transpose B is defined if the number of columns in A transpose, that is 3, that should be equal to the number of rows in B, that is M. So M is equal to 3. And BA transpose is also defined if the number of columns in B is N, that should be equal to the number of rows in A transpose, which is 4. N is 4 and M is 3. So therefore B should be of the order 3 cross 4. So option B is the correct answer. Then the symmetric part of the matrix is, we have to find the symmetric part. Since why we know that any matrix A can be written as the sum of the symmetric matrix, which is A plus A transpose, and the skew symmetric part, which is half into A minus A transpose. So now A transpose, the matrix A transpose will be, we have to reverse the matrix, means we have to change the rows into the columns and the columns into the rows. So this will be 1 6 2 2 8 minus 2 and 7. Now therefore A plus A transpose, that will be equal to A, which is 1 2 6 8 2 minus 2 7, that plus with this, which is 1 6 2 8 minus 2 7. So if we add them, then we'll get 1 plus 1 2 8, 4 plus 2 6, 6 plus 2 8, 8 plus 8 16, 2, 2 minus 2, that is 0, plus 4, that is 6, and minus 2 plus 2, that is 0, 7 plus 7, that is 4. Now therefore the symmetric part, now therefore the symmetric part of the matrix A, that is half of A minus half of A plus A transpose. That will be equal to half of this, which is 1, 4, 3, 4, 8, 6, 7. Option D is the correct answer. Then here it is told, if A is a matrix of order 3 such that A into adjoint of A into adjoint of A, that is 10 into I, then the determinant of adjoint of A is how much? So now therefore the determinant of A into adjoint of A determinant of A into adjoint of A, that is given as the determinant of A whole power n, where n is the order of the matrix. That will be equal to determinant of A whole power 3. So that is the determinant of 10 into I. So it means it will be 10 power 3 into the determinant of I, which is 1. So therefore the determinant of A, that is equal to 10. Therefore the determinant of adjoint of A equal to the determinant of A whole power 2 whole power n minus 1. Since why this is the determinant of A whole power n minus 1, and n is equal to 3 here. Since it is a order, it is a matrix of order 3. So that is the determinant of A whole square. So determinant of A is 10, so this is 10 square, which is 100. Option C is the correct answer. Question number 40, it is told, consider the following statements. If any two rows or columns of a determinant are identical, then the value of the determinant is 0. Any two rows or columns of a determinant are identical, then the value of the determinant is 0. So obviously it is true. This one is true. If the corresponding rows and columns of a determinant are interchanged, the value of the determinant does not change. So only it will become negative. The value will not change, but the sign will change. If any two rows or columns of a determinant are interchanged, then the value of the determinant changes in sign. Yeah, so third one is true. So the second one, if the corresponding rows and columns of a determinant are interchanged, value of the so okay, so it means that if we take the transpose of the matrix, then the value of the determinant will not change. So second one is also true. So all the given statements are true. So option C is the correct answer. The inverse of this matrix is, the inverse of this matrix we have to find. So we know that the inverse of the matrix A is given by the adjoint of A by the determinant of A. Now the determinant of A, that will be equal to the determinant of 2 0 0 0 3 0. This will be equal to 2 into 3 4s are 12 minus 0, then minus 0 into something, that will be 0 only, plus 0 into something, that is 0. That will be equal to 24. Now we have to find the adjoint. For the adjoint, we have to find the transpose of cofactor matrix. Cofactors we have to find. The cofactor A11, that is equal to minus 1 whole power 1 1 1 plus 1 to M11, which is 3 0 0. The determinant of the remaining part by removing the first row and first column. You have to take the determinant of this. The determinant of this, so this will be 12. Then A12 be first row and second column we have to remove. First row and second column, that will become 0 only. And A13 is, you have to remove the first row and third column. That will be also A4 equal to, sorry, it is A21, sorry. A21 will be, we have to remove the second row and first column. It will be 0 into 4 minus 0 into, that will be 0 also. And A22 is minus 1 raised to minus 1 whole raised to 2 plus 2, and into, we have to remove the second row and second column. So this will be 2 4 the 8. So this will be 8. And then A23, that will be equal to minus 1 whole power 2 plus 3 into, that will be, we have to remove this first, we have to remove the second row and third column. So this will become 0 also. Then A33 will be equal to minus 1 whole raised to 3 plus 3 into A33. A33 means we have to remove the third row and third column. So it's 6. Therefore, the inverse of the matrix A. Inverse of the matrix A is A inverse. That will be equal to that is 1 by determinant of A, which is 24, into the cofactor transpose, that is matrix A11, A12, 3, A21, A22, A23, A31, A32, 33. That will be equal to 1 by 24 into A11, 12, 0 is 12, 0, 0, and A21, 0, 8, 0, 0, 8, 0. Then this will be A31, A33 is 6, A31, the third row, first column we have to remove, so that will be 0, and A32 also, that will be third row and second column we have to remove, that will be 0. That is 0, 0, 6. 0, 6. So you can write it as 12 by 24, that is by 2, and this is 8 by, that is 1 by 3, is 0, 6, 4. Means that option D is the correct answer. Then here it is told, if A, B and C are in AP, then find the value. So then what we can do, we can write this, we can write the given determinant as delta, that is equal to x plus 2, x plus 3, x plus A, x plus 4, x plus 5, x plus B. This is x plus 6, x plus 7, x plus C. So then if we multiply the first row, sorry, the second row with 2, and then if we multiply this, we can multiply this determinant by half, and we can multiply 2 with the second row. Then we will have x plus 2, x plus 3, x plus a, 2x plus 8, 2x plus 10, 2x plus 2b. Write it side. So therefore the delta can be written as half into the determinant of x plus 2, x plus 3, x plus a. Here we will have 2x plus 8, 2x plus 10 plus, sorry, 2x plus 2b. This will be x plus 6 and this will be 7. See. So now what we can do, we can say that a, b, c are in AP. It means that 2b, that is equal to a plus c. Since here it is told a, b and c are in, therefore we can write it as half of, then we can apply the row operation, that is R2 goes to R2 minus R1 plus R3. 2 minus R1 plus R3. This is x plus 2 first row, this is x plus 3. Then from the second row, we have to subtract the sum of first and third rows. 2x plus 8, that will be 0 again. This will be plus 10, will become 0. And 2x plus a plus c, that will be, this will be x plus 6 plus 7 x plus c. So if we expand this determinant along the third row, so we will say that on expanding the determinant, which is delta, along the second row, we will get the value as, we get the value of delta as 0. So option A is the correct answer. Then here it is told the system of linear equations has no solution when the system of linear equations, which is x plus y plus z equal to 6 and x plus 2y plus 3z, that is equal to 10, x plus 2y plus az, b. It will have no solution under which condition? So it will have no solution, will have solution if, so we can write this as ax into ax equal to b, so x will be equal to a inverse into b, that can be written as b into adjoint of a divided by the determinant of a. So it will have no solution if the determinant of a is 0 but b into adjoint of a, it is not equal to. So now therefore the determinant a, that will be equal to the determinant of 1 1 1 3, this is 1 2 a, that should be equal to, means we can say that we expand this determinant along the first row, then we will have 1 into 2a minus 6 minus 1 into a minus 3, then plus 1 into 2, that should be equal to 0. It means what? It means that 2a minus 6 minus a plus 3, this is 0 only, is equal to, so it means that a should be equal to 6 minus 3, that is 3. A should be equal to 3. We have to find the value of b. It is told that b into adjoint of a should not be equal to, Or we can say that from here we can find out x. How? X is equal to the determinant d1 by determinant of a, where d1 is what? D1 say is equal to the determinant of, which is 1 2 2 1 2 2 1 3a 3a, and the coefficient matrix, where B matrix is actually 6 10 B. So here is that 10 6 10. Now this should not, so one, so if the determinant of A is 0 but D1 is not equal to 0, then also it has no solution. So it has no solution. Then also we have solution. Okay, so therefore the matrix D1 should not be equal to 0. What means the determinant of 1 2 2 1 3 A is how much? A we have found it as 3, so this will be 3, and 6 10 B. This should not be equal. Therefore, if we expand this determinant along the first row, then we will have 1 into 3b minus 30 minus 1 into 2b minus 20 plus 6 into 0 6 6 minus 6, that should be equal to 0. So therefore this should be 3b minus 30 minus 2b plus 20, that is equal to, so this will be b, that is equal to 10. So sorry, this should not be equal to 0, means b should not be equal to 10, should not be 10. A is equal to 3 and B should not be 10. So option A is the correct answer. Now question number 44, it is told if the matrix A is 0 1, then A square is how much? So A square will be equal to A into A, that will be equal to 0 1 0. That will be, we have to multiply first row with first column, the 1, first row into second column 0, and then second row into first column 0 I actually. So option D is the correct answer. Question number 45 told if matrix A is alpha 2 alpha, then and the determinant of A cube 7, alpha is equal to how much? Okay, so we know that the determinant of A cube, that is equal to the determinant of A whole cube, is equal to 27. Therefore the determinant of A, that is equal to 3, since it is the cube root of 27. So now alpha can say that the determinant of A, that is equal to determinant of alpha 2 2 alpha, that should be equal to 3. It means that it is alpha square minus 4, that should be equal to 3. So alpha square should be 7, or should be equal to plus or minus root 7. Option D is the correct answer. And in question number 46, it is told that if the determinant of 2a x1 y1, 2b x2 y2, 2c x3 y3 is equal to ABC by 2, that is not equal to 0. The area of the triangle whose vertices are these. Therefore, the area of the triangle will be b equal to is the determinant of x1 by a, y1 by a 1, then x2 by b, y2 by b, then 1, then x3 by c, y3 by c, then 1. You have to find this. So we can take 1 by a as common from the first row, and 1 by b as common from the second row, and 1 by c as common from the third row. Then we can write down that will be the into the determinant of x1 y1 a, x2 y2 a, x3 y3, sorry, this is b, c. Now if we take 2 as common from the third column, then we can write it as 1 by 2 to 2a, 2b and 2c. Take half as common, third column, sorry. So then we can interchange okay. Then we can interchange the first column this with the second column, and then we can interchange the second column with the third column. We can interchange the first column with the second column. Then we can interchange the third column with the first column. Then we will have, therefore we will have the area will be equal to 1 by 2 ABC. 2, that will be the determinant of is 2a will come in front, then 2a. First I will do C1 and C2 will be interchanged, C1 and C2. So x1 x3 will come here, y3 will come all, and then we will interchange first column with the third column. Is that this y3 will come here and this 2c will go here. Therefore we will have 1 by 2 ABC into this is 2a x1 y1, then 2b x2 y2, 2c x3 y3. So now this value given as ABC by 2. This will be 1 by 2 ABC. This is ABC by 2. ABC will cancel. So this is 1 by 4 square root. So option D is the correct answer. 1 by A, this is 1 by 2. By 4 is the correct answer. So option D is the correct answer. Then question number 47, it is told to evaluate the value of cos 15. We have to evaluate the determinant of cos 15 degrees, sin 15, sin 75 degree, cos 75 degree. So this will be equal to cos 15 into cos 75 minus sine 15 into sine 75. So this is like cos A cos B minus sin A sin B. So this is formula for cos 15 plus 75. 15 degree plus 75 degree, that is 90 degree. So this is cos 90 degree. That is equal to 0. Option A is the correct answer. Then number 48, it is told if x, y and z are all different and not equal to 0, x is not equal to y, not equal to z, x and y, z are all different and not equal to, and the determinant of 1 plus x 1 1 1 y 1 1 1 plus z, that is equal to 0, then find the value of this x inverse plus y inverse. Then that will be equal to 1 by x plus 1 by y plus 1 by z. This you have to find. So if we expand this determinant, then we will have, we can do r1 equals to r1 minus r3. So then we will have x1, this will be 0 and 1, so this will be z minus z, 1 plus y 1 1 z. That we are applying this row operation. Then if we apply the row operation, that is r2 goes to r2 minus r3. So we will have the determinant of x0 z 1 minus 0, this is y, this is minus z plus z 0. We have this. Then if we expand this determinant along the first row, we have x into y into 1 plus z into y into 1 plus z minus of minus z, that is plus z plus z. Then plus 1 into this will be 0 minus of minus zy, that is plus yz, that is equal to 0. So this will be, implies that this will x into y plus yz plus z plus yz is equal to have xyz plus xy plus zx plus yz plus zx, that is 0. Now therefore if we divide by xyz, then we have 1 plus 1 by z plus 1 by x plus 1 by 0 by x plus 1 by y plus 1 by z, that is equal to minus 1. Option D is the correct. Then in question number 49, A is any square matrix of order 3 cross 3, then the determinant of 3A is equal to, A is any square matrix of order 3 cross 3. So then the determinant of, so determinant of 3A will be 3 power n to the determinant of, where n is the order of the, let's say, be 3 power 3 into the determinant of A, which is 27 determinant of A. Option C is the correct one. Then in question 50 it is told A is equal to 1 by pi sine inverse pi x, tan inverse of x by pi, sine inverse of x by pi, cot inverse of pi x, and b is equal to also 1 by pi into minus cos inverse pi x tan inverse x by pi, then sin inverse x by pi minus tan inverse. So now therefore a minus b, if you do, that will be also equal to 1 by pi into this minus this. So this will be sin inverse pi x plus cos inverse pi x. This will be tan inverse x by pi minus tan inverse x by pi, that is 0. Sin inverse x by pi minus sin inverse x by pi. Then cot inverse pi x minus of minus tan inverse pi x. This is tan inverse pi x plus cot inverse. So this is equal to pi by 2. This is also equal to pi by 2. So this will be, I can say 1 by pi into pi by 2, 0, 0 pi by 2. So from here, pi by 2 if I take as common outside, so this will be pi by 2 into 1 by pi, 0, 0. This will be pi will cancel, so this will be half into I. I is the identity. And D is the correct answer. Then in question number 51, it is told A is a matrix of the order m cross n, and B is a matrix such that A, B transpose and B transpose A are both defined. Then order of the matrix B is how much? So let the order of the matrix B is P cross Q. Now therefore, order of the matrix B transpose be P Q cross P. Q cross P. Now, so if AB transpose is defined, AB transpose is defined, then A is of the order m cross n of the order Q cross P. Therefore, Q should be equal to n. Is the number of columns in A should be equal to the number of columns in B transpose. And B transpose A is defined. B transpose A is defined, then you can have, so the order of B transpose is Q cross P. A is of the order m cross n. So P should be equal to m. P is equal to m, Q is equal to n. So B also should be of the order m cross n. And D is the correct answer. Then in question number 52, it is told if x, y, z are not equal, x, y, and z are not equal and not equal to 0 and not equal to 1, then the value of the determinant of log z, log y, log z, log 2x, log 2y, log 3z, sorry, log 2z, log 3x, log y, 3z. So we know that log of AB, that is equal to log of A plus log B. Therefore, this determinant can be written as log x, log y, log z. Here we can write it as log 2 plus log x. Similarly, here we can write log 2 plus log y. This is log 2 plus log z. And this is log 3 plus log x plus, and this is log 3 plus log y, and this is also log 3 plus log z. So now here if we subtract, if we do r1 goes to r1 minus r2, and r3 goes to r3 minus, sorry, r2 goes to r2 minus r1, and r3 also goes to r3 minus r1. So if we apply this row operations, then we will have this will be log x, log y, log z. This will be log 2, log 2, log 2. This is also log 3, log 3. Then we can take log 2 and log 3 as common from the second row and third row. Then we have log 2, that will be the determinant of log x, log y, log z. It will be 1, 1, 1. And now since the second row and third row are identical, here R2 and R3 are identical. That is why the value of the determinant will become 0. So it will be option C is the correct answer. Then in question number 53, told that if the matrix A, that is equal to the determinant of cos 2 theta minus sin 2 theta, sin 2 theta, cos 2 theta, and A plus A transpose, that is equal to I, where I is the unit matrix of 2 cross 2, A transpose I is the matrix, so I is 1, 0, 0, and A transpose is the transpose of A, then the value of theta is equal to, therefore A plus A transpose equal to cos 2 theta minus sin 2 theta, sin 2 theta, 2 theta, plus A transpose will cos theta, sin 2 theta, minus sin 2 theta, and 2 theta. So this will be equal to 2 cos 2 theta, this will be 0, and this will be also 0, and this will be 2 cos 2 theta. That is equal to 1, 0, 0, 1. So therefore simply we can say that is cos 2 theta, that is equal to 1, cos 2 theta, that is equal to half. So it means that 2 theta should be equal to 2n pi plus minus pi by 3. That theta should be n pi plus or minus pi by 6, where n belongs. So this is the general solution. If we put n equal to 0, then we can get minus pi by 6 and plus pi by 6. So here we have one of the options as pi by 6. So option A is the correct answer. Here it is told if the matrix A is 3, 1, minus 1, 2, then A square minus 5A is equal to, okay. So A square means A into A square, that is equal to 3, 1, minus 1, 2, 3, 1, minus 1, 2. That will be the matrix. We have to multiply the first row with the first column. So is 3, 3 the 9 minus 1. This will be 3 plus 2. This is minus 3 plus minus 3 minus 2 minus 3 2. This is minus 1 plus 4. This will be equal to 8, 5 minus 5. So this one is A square, and then 5A, that will be equal to 5 into 3, 1 minus 1, 2. This will be equal to 15, 5 minus 5, 10. So then therefore A square minus 5A, we have to find the value of A square minus 5A. That will be equal to A square, which is 8, 5 minus 5, 3, and then minus 5A, which is 50, 5 minus 5, 10. So that will be equal to 8 minus 15, that is minus 7, 5 minus 5, 0, 5, 5 that is 0, 3 minus 10, that is minus 7. So that is equal to minus 7 into I, minus 7I. Option D is the correct answer. Then in question number 55, it is told if A is a square matrix of the order plus 3, then Ka, the determinant of Ka will be how much? So determinant of Ka will be K power n and the determinant of here n is the order of the matrix A, which is 3. So it will be K power 3 into the determinant of A. So option D is the correct answer. So then in question number 56, it is told if a matrix A is both symmetric and skew symmetric, then A is what? Is that a matrix A is both symmetric and skew symmetric? It means A transpose is equal to A, which is also equal to minus A. It means that 2A that is equal to 0 matrix. So A should be 0 matrix. Option B is the correct answer. Then in question number 57, it is told solve this equation. It is told the determinant of 3x x1, that is the determinant of this will be 3 minus x square, that is equal to 3 minus 8. Is that x square equal to 8? 3 and 3 will cancel, minus minus. So x square equal to 8. So x should be equal, what x will be equal to root 8, which is 2 root. Therefore x will be equal to plus or minus 2 root. Option C is the correct answer. Then in question number 58 is told that if 2 into matrix 1 3 0 x plus y 0 1 2, that is equal to 5 6 1 8, then the value of x and y are. So you can write this will be 2 6 0 2 x plus y 0 1 2, that is equal to 5 6 1 8. So therefore you can say that 2 plus y 6, and this will be 0 plus 1 1 plus 2x plus 2, that should be equal to 5 6 1 8. So therefore 2 plus y, that should be equal to 5, and 2x plus 2, that should be equal to 8, y should be equal to 3, and x should be 6, x should be equal to 3, x equal to 3 and y equal to 3. Option A is the correct answer. Then question number 59, it is told the area of the triangle with vertices k0 4 0 0 comma 2 is 4 square units. K comma 0 is a point on the x-axis. Let's say it is k. This is 4 0. So k can be here also, it can be here also. This is 0 comma 2 on the y-axis. We have to find the area of this triangle. The area will be equal to half base into height. Half base is equal to k minus 4, which we can write mod of k minus 4 into height. Height is equal to 2 units. It is 2. So that is equal to 4 square units. So is that mod of k minus 4, that is equal to, is that k minus 4, that is equal to plus or minus 4. So k should be equal to 4 plus or minus 4. Means k can be equal to either 0 or 8. Option D is the correct answer. Then number 60, it is told you have to find the matrix A minus B. So it will be 1 by pi into, it will be sine inverse pi x minus of minus cos inverse pi x. So this will be sine inverse pi x plus cos inverse pi x, tan inverse pi x, tan inverse x by pi minus tan inverse x by pi, that is 0. Sine inverse x by pi minus sine inverse x by pi, that is 0. But actually B here, it should have been 1 by pi. Here there is something wrong in the question, we should rectify it. So here B should be 1 by pi into this. This should have been given. So here say that this will be sine inverse x by pi minus sine inverse x by pi, that is 0, and cot inverse pi x minus of minus tan inverse pi x, that is tan inverse pi x plus cot inverse pi x. This will be 1 by pi into this will be pi by 2, 0, 0, pi by 2. So pi by 2 I can take as common outside from the matrix. So this will be 1 by pi into pi by 2, 1, 0, 0, that is I. So it is half into I. So option A is the correct answer. Then in question number 61, it is told that the let the let delta be equal to the determinant of ax x square 1, by y square 1, cz z square 1, and delta 1 be the determinant abc xyz zy zx xy. Then which is true. Okay, so now here so from the determinant delta we can take x as common the first row, then we will have x outside, and y if I take as common from the second row, then into y, and z as common from the third row, then into z, into I will have a x 1 by x, and this will be b y 1 by y, this will be c z by z. Similarly, from delta 1 also, the determinant delta 1 also, we can take uh, xyz as common from the third row, then we will have xyz into abc xyz. This is 1 by x, 1 by y, and 1. We can take the transpose of this also. This will be xyz to the determinant of abc xyz 1 by x, 1 by y, 1. Therefore, we can see that they are the same. Therefore, we can say that delta 1 equal to delta. So option B is the correct answer. Then question number 2, question number 62, it is told if A is the matrix 2 minus 2 minus 2 2, then A power n, that is equal to 2 power ka, where k is equal to how much? Okay. So now we can, from the matrix A, suppose if we do A square, then we will have 2 minus 2 minus 2 2 into this 2 minus 2 minus 2 2. That will be equal to 2 4 4 plus 4, that is 8. This is 2, that is minus 2 minus first row into second column, so minus 4 minus 4 minus 8. This will be also minus 4 minus 4, that is minus 8 plus 4, that is 8. This will be equal to 4 into minus 2 minus 2 2, that is 2 square. Now similarly a cube be equal to a square into a again. This will be 8 minus 8 minus 8 8 into again minus 2 minus, this will be again 2. So this will be equal to a to the 16, 16 plus 16, that is 32. This will be equal to, it is a 16 plus 16, that is minus 32. This is also minus 32, and this will be this we can, from here 16 I can take as common, so this will be 2 minus 2 2 2. So 16 will be equal to 2 power power 4. Power 4 into a, that is. And this is 2 square into a. And a power 1, if I do, that is equal to power 0 into. So it is going like 0 to like this. Means therefore, you can say that so a power n equal to 2 power ka. So here, if n is equal to 1, then k is equal to 0. And if n is equal to 2, then k is equal to 3. So then k is equal to 2. And if n is equal to 3, then k is equal to 4. So the first term is 0, second term is 2, third term is 4. So it is going like AP term is 4. Then a power 4, that will be a cube, and that will be again a cube is actually 2 power 4 to a into a again. This 2 power 4 into a square. A square is again power 2 is equal to 2 power 6 into a. It means when n is equal to 4, then k is equal to 6. It means that only the even terms we are getting, only the even numbers. So therefore, a power n, so the third term, so first term is 0. So therefore, the nth term, an, that is equal to a plus 1 into t, which is 2. It's 2 into n minus 1. So a power n, that is equal to 2 power 2 into n minus 1. So it means that option D is the correct answer. Then in question number 63, it is told if matrix 1 1 minus 1 1 into x y, that is equal to matrix 2, then the values of x and y are respectively. Here we have to multiply first row with this with the first column, so it will be x plus y, and then first and then second row into first column minus x plus y, that is equal to 2 4. So therefore x plus y, that is equal to, and minus x plus y, that is equal to 4. If we add them, then we will have 2y, that is equal to 6. Add them, so that y equal to 3, and then so if y equal to 3, then x is equal to minus 1. X is minus 1 and y is 3. So option D is the correct answer. Then it is told A is equal to the matrix cos alpha, sin alpha, minus sin alpha, cos alpha. Then A into A transpose, that is equal. So now A into A transpose, A into A transpose, that will be equal to cos alpha, cos alpha, sin alpha, minus sin alpha, cos alpha, into cos alpha minus sin alpha, sin alpha minus cos alpha, sorry, sin alpha, cos alpha. So that will be equal to the matrix. We have to multiply first row with first column. That is cos square alpha plus sin square alpha. This will be minus sin alpha cos alpha plus sin alpha cos alpha. Then this will be minus sin alpha cos alpha plus sin alpha cos alpha. This will be sin square alpha plus cos square alpha is equal to, so this is 1001, which is equal to I. Option D is the correct answer. Then in question number 65, it is told if x, y, and z belong to R, the value of this determinant is. So it means from the options we can see the value of the determinant is independent of x. From the options we can observe. Options we can see that the value of the determinant A, value the determinant is independent of x. It's independent of x. So it means that we can put any value of x, then also the value will come the same. So therefore, let us put x equal to 0. Therefore, then the matrix A will be 2, that is 5 power 0 plus 5 power is 1. 1 plus 1, that is 2. So 2 square is 4. This is 1 minus 1, 0, 1. This is also 1 plus 1 whole square, 1, 0, 1. This is again, this is 0, this is 1. From here we can see that all the elements in the second column are zeros. Therefore, the determinant will be 0. The determinant is 0. Option D is the correct answer. Then question number 66, it is told to find the value of this determinant. Value of this determinant we have to find. For the determinant of A minus B, B minus B plus C, A, B minus A, C plus A, B, C minus A plus C. So here we can do one thing. Here we can apply the row operation. That is C1. C1 goes to C1 minus C3. C1 minus C3. So then we will have the determinant of minus B, B plus C, A. Then minus A, C plus A, B. Minus A, B, C. Then we can do C3 goes to, sorry, C2 goes to C2 plus C1. So we are applying the column operation. If we apply this column operation, then we will have minus B, A, minus A, minus A, and this is B plus C plus minus B, that is C, and this will be C, this will be again B, and this will be A, B, C. Okay. Then this will be equal to, if we expand this, okay, this determinant, if you expand it along the first row, if we expand the determinant, the first row, then we'll have minus B into C square minus B square minus C into minus AC plus AB, then plus A into minus AB plus AC. This will be minus BC square plus B cube plus AC square minus ABC minus AB square, sorry, minus A square B, A square B, A square C. Determinant. Sorry, here we can do something. We can apply the column operation, which is C2 goes to C2 plus C3. Then we will have the determinant of minus B minus A plus B plus C, is A plus B plus C, A plus B plus C, A, B, C. So from the second column, we can take A plus B plus C as common. A plus B plus C into the determinant of minus b minus a 1 1 a b c. So then here we can do a plus b plus c. We expand this along the first row, have minus b into c minus b minus 1 into c minus b into 1 into minus ac, sorry. So minus 1 into minus ac is ab, then plus a into minus a of minus a, that is plus a. This is 0. This will come a plus b plus c into minus bc plus b square, c plus b square, then plus ac cb, ac minus ab. Then we can say this is a plus b plus c. Here we can take from here we can take we can write it is c into a minus b and minus b into a. This will be equal to a minus b into c minus b into a plus b plus c. It means that none of the options are correct. Then here no options are correct. None are correct options. So here question number 67. Number 67, it is told if x1 y1 x2 y2 and x3 y3 are the vertices of a triangle, the area is k square units, then the value of this is how much? So you have to find the value of the determinant of x1 y1 4, x2 y2 3, y3 4 square. So now therefore we know that the area of the triangle will be a, that is equal to the determinant of x1 y1 1, x2 y2 1, x3 y3 1. So now from here, if we take 1 by 4 as common, so therefore if we multiply 4 on both sides, and if we multiply 4 with the third column, then we have x1 y1 4, x2 y2 4, x3 y3 4. Then if we take the whole square on both sides, so therefore it will be 16 times the square of the area. So if the area is told, that is k, area is k, so therefore it should be 16k square. Option B is the correct answer. So we have multiplied 4 with the third row, square of that. So option B is the correct answer. Then in question number 68, it is told if A be a square matrix of order 3 cross 3, A is a square matrix of the order 3 cross 3, then the determinant of 5A, that is how much? So that will be equal to 5 power 3 into the determinant of A, which is 125 into. So option B is the correct answer. Then in question number 69, we have to find the inverse of this matrix. So it is given 2 5 0 0 minus 1 0. So If we take this as the matrix A, then A inverse will be equal to the adjoint of matrix A by determinant of A. Now the determinant of A will be equal to 2 into 3 minus 0 minus 5 into 0 plus 1 plus 0. This will be 2 3 6 minus 5, that is equal to 1. So now therefore the adjoint of the matrix A, adjoint of matrix A, that is equal to the transpose of cofactor matrix. This is A11, A12, A13, then A21, A22, A3, A31, A32, A33. We have to find these cofactors. So A11 will be minus 1 whole raised to 1 plus 1 to the determinant of 1103, that is equal to 3. Then A12, that is equal to minus of first row and second column we have, so 0 minus of minus 1, so plus 1, that is 1. Then A13, that will be equal to first row and third column we have to remove, so 0 minus of minus 1, that is plus 1. Then A21, that will be equal to minus of second row and first column we have to remove, 5 3 is 15. Then A22 will be equal to second row and second column, 2 3 are 6, 6 minus 0, so that is 6. Then A23, that is minus of second row and third column, this is 2 0 0 minus of minus 5, that is plus 5, that is minus 5. So then A31, that is equal to first, so third row, first column, third row and first column we have to remove, so 5 ones are 5 minus 0, 5 minus 0, so that is 5. Then A32, that is minus of, we have to remove third row and second column, third row, second column, 2 minus 0. A33, that is minus of, we have to remove third row and third column, third column, so it is 2 minus 2. Now therefore the adjoint of matrix A, that is equal to A12, that is so 3 minus 1 1, 3 minus 1 1, and then A21, that is minus 15, 6 minus 5, and it's 5 minus 2 minus 2. So therefore now an inverse of matrix A is adjoint of A by determinant of A. Now the determinant of A is 1, so therefore the adjoint only is the inverse. So this is the answer, which is equal to the adjoint of A, since the determinant of A is 1. So that is option number minus 15, 6 minus 5. Option D is the correct answer. Minus 16 is A22. Option D is the correct answer. Okay. Okay, then number 70, it is told if P and Q are symmetric matrices of the same order, that symmetric matrices of the same order, then that means that P transpose equal to P and Q transpose, that is equal to Q. They are of the same order also. Then PQ minus QP is an identity matrix or zero matrix, symmetric matrix or symmetric matrix, that we have to find. So we have to find the transpose of this whole thing. That will be equal to PQ whole transpose minus QP whole transpose. That will be equal to Q transpose into P transpose minus P transpose into Q transpose. Q transpose is Q, P transpose is P, it's PQ. QP minus PQ, which is minus of PQ minus QP, which is Q symmetric. It means that matrix PQ minus QP is the skew symmetric matrix. So option D is the correct answer. Then it is told if the matrix 3A plus 4B transpose, that is 7 minus 10 17 0 6 31, and 2B minus 3A transpose, that is equal to minus 1 18 4 0 minus 5 minus 7, then B is how much? So we can take the transpose of this first matrix. Then therefore we'll have 3A transpose plus 4B. 4B transpose whole transpose, since B transpose whole transpose is B only. So that will be 4B, that is equal to the transpose of this whole thing, which is 7 0 minus 10 17, sorry, minus 10 6, this is 17 31. So 4B this is, and this is 2B. Therefore if we add them, then these two will cancel, then we'll have 6B. 6B is equal to, you have to add them. This is 6, this is 18, 4 plus 4 minus 10, that is minus 6, 0 6, and then 17 minus 5, that is 12, 31 minus 7, that is 24. So therefore B will be equal to 1 3 minus 1 1 minus 2. So matrix B is 1 3 minus 1 1 minus 2. This is 6, sorry, this is 12, 24, this is 2 and 4. So it means that option C is the correct answer. 1 1, sorry, 1. So option A is the correct answer. Then question number 72, A, the matrix A is this, matrix B is this, then the determinant of A B B transpose is, therefore now B into B transpose that we have to find, B equal to minus 1 1 2, then 1 1 2, that this will be equal to first row into first column, 4 plus 1, that is 5, 1 5, this will be 2 2, that is 0, 2 minus 2, that is 0, 1 plus 4, that is 5. Now therefore A into B transpose, that will be equal to A, which is 1 B 4 2, into that is 5 0 0 5, equal to 1 5, that is 5 plus 0, that is 5, 1 plus 15, 15, 5 is 20, 3 plus 0 is 20, 5 is 10. Therefore the determinant of this, determinant of AB transpose, that is 5 tens of 50 minus 5 tens of 30, so 300, that is equal to minus 250. Option C is the correct answer. Then question number 73, it is told if the value of a third order determinant, the let the determinant of A is equal to 16, then the value of the determinant form by replacing its elements by its cofactors is. So now it means we have to find the determinant of the adjoint of transpose. Since the transpose of the adjoint will be equal to the matrix which is formed by replacing its elements by the cofactors. So the determinant of the transpose of adjoint, that is equal to the determinant of the adjoint A, which is equal to the determinant of A whole power 3 minus 1. Since the order of matrix A is 3, which is determinant of A whole square, that is 16 square, which is 256. Option B is the correct answer. Then the constant term in the expansion of this. So whenever we need to find the constant term, we need to simply keep the value of x as 0. Since why it will come a cubic, if you expand it, one cubic polynomial will come. So in the cubic polynomial, so if I tell p of x, that is equal to ax cube plus bx square plus cx plus d plus cx plus d, then p of 0, that is equal to d. So it means that, so if we put x as 0, if we put x equal to 0, then we can find the constant term. We can find the constant term. So it means, therefore, the constant term, that will be constant term in the expansion of this, that will be equal to the, the determinant of, if we put x equal to 0 here, this will be 1 minus 1. If we have to put x as 0, that will be 2 minus 1, 2, 1. Sound. So therefore the constant term, that will be equal to 1 minus 1 2 minus 1 2 1 minus 2 1 minus 1, that will be equal to 1 into, we can expand this determinant along the first row, expand the determinant along the first row, then 1 into minus 2 minus 1, then minus of minus plus 1 into 1 plus 2, then plus 2 into minus 1 minus of minus 4, that is plus 4. This will be minus 3 plus 3, then this will be 3 to the 6 plus 6. So 3 and 3 will cancel, that is equal to 6. So 6 is the required constant term. Option D is the correct answer. Then question number 75, it is told that if matrix A is this, if the matrix A is 0 0 1 0 1 0 0 0, then A power 4 is how much? A power 4. So first we can find A square. So A power 4, we can write it as A square whole square. So A square into A square. So A square we can find first. So which is 0 0 1, A square is A into A. Be the product of A with itself. 0 1 0 1 0 0 2 0 0 1 0 1 0 1 0 0 will be equal to, we have to multiply first row with the first column. So this will be 1, and then first row into second column, that is 0, first row into third column, that is 0, and second row into first column, that is 0, second column 0, second row into second column, that is 1, second row into third column, that is 0, row in third row into first column, that is 0, third row into second column, that is 0, third row into third column, that is 1, is equal to I. Therefore A power 4, that is equal to I into I square, which is also equal to I. Since I power n, that is also equal to I. Okay, so option B is the correct answer. Then question number 76, if f of x is this, then we have to find, so first we can find f of 0. First we have to put x equal to 0 here, that is the determinant of 0 minus 0, that is 0 a, and this is b, and this is minus a 0, c minus b, c 0. So that will be equal to, so we can expand this determinant along the first row. This will be 0 minus of minus c square, that is plus c square, minus a into, this will be 0 minus, so plus bc, then plus b into, then ac minus 0. So this will be minus abc plus abc, that is equal to 0. Then f of 2 will be equal to, f of 0 is 0. It means that we have, so here only single option is correct. Single option is correct. Therefore, option B is the only correct answer. Then question number 77, if A and B are square matrices of the same order and B is a skew symmetric matrix, so it means that B transpose is equal to minus B, and nothing has been told about the matrices, so we have to find if A transpose BA is null matrix or diagonal matrix or skew symmetric matrix or symmetric matrix. So first we can find its transpose. B equal to, say this is transpose into BA whole transpose, I can write. So this will be BA whole transpose to A transpose whole transpose. This will be BA transpose means it is BA whole transpose into A. BA transpose is A transpose into B transpose into A. B transpose is minus B, so it is minus of A transpose B. Therefore, A transpose BA is Q symmetric matrix. So therefore, option C is the correct. Then in question number 78, it is told that if 2, 1, 3, 2, A is equal to 0, 1, which is I, then the matrix A is. So simply, therefore, here B into A, let's suppose if we take this matrix as B, then B into A, that is equal to I. So it means that if we pre-multiply both sides with B inverse, have B inverse into I, B inverse into B is I, so I into A, that is equal to B inverse. So I into A is A, so A is equal to B inverse actually. Therefore, we need to find A, the matrix A, which is nothing but, A is nothing but the inverse of 2, 1, 3, 2. So that will be equal to, so first we have to find the adjoint of B divided by the determinant of B. Now the determinant of B is equal to 4 minus 3, that is equal to 1. And the adjoint of B, that is equal to the transpose of cofactor matrix, that is B11, B12, B21, B22. So therefore B11 is first row and first column we have to remove, that is 2. Second row, then B12 means first row and second column we have to remove, that is minus 3, and then we have to, B21 is second row and first column we have to remove, that is minus 1, and then B22 means second row and second column we have to, that is 2. So therefore A is this matrix only, it is 2 minus 1 minus 2. 2 minus 1 minus 3, 2. So option A is the correct answer. Then question number 79. Question number 79, it is told if A1, A2, A3 till A9 are in AP, then the value of this matrix is. So we can say that A4 is what? A4 is A plus 3D. A5 is what? A5 is A plus 4D. And A6 is what? A6 is A plus 5D. Therefore, what we can do, we have to find the determinant of A1, A2, A3, A4, A5, A6, A7, A8, A9. Then what we can do, we can apply the row. So we can apply the column operation, which is C2 goes to C2 minus C1, and C3 goes to C3 goes to C3 minus C1. If we apply these column operations, then we will have the determinant of. So now here simply we can say that A2 minus A1, that is also equal to A5 minus A4, that is also equal to A6, A8 minus A7, that is also equal to D. And whenever we do A3 minus A1, that is also equal to A6 minus A4, that is equal to A9 minus A7, that is equal to 2D. So this will be A1, A4, A7, and this will be D, this will be D, this will be D, and this will be 2D. This will become 2D, this will become. From here, from the second column, we can take D as common. And from the third column also, we can take 2D as common. So this will be 2D square will be outside. 2D square into the determinant of A1, 1, A2, so this is A4, A7, and this is 1. So 2D, this is also 1. So the second column, the third column are identical. Here the second column and third column are identical. Therefore, the value of the determinant will be 0. So the answer is 0. So here log e base e, that is equal to 1, and log 1 base e, that will be 0. So option B is the correct answer. Then we can solve the last question of chapter matrices and determinants. So chapter on matrices and determinants, the last question, that is question number 80, we can solve. If A is a square matrix of order 3, then and determinant of A is equal to 5, then the determinant of A into adjoint of A, determinant of adjoint of A into adjoint of A is how much? So that is equal to the determinant of A into the determinant of adjoint of A. That is equal to the determinant of A and determinant of A whole power n minus 1. That is equal to determinant of A whole power n, where n is the order of the matrix A. So it is simply the determinant of A 3. So that is 5 power 3, which is 120. Option A is the correct answer. So hope you have understood the solutions of all these 80 questions. So in any of the steps of the solutions, if you are able to understand, or any other doubts if you have, then please write us in the comments section. And any other chapter in maths, if you feel it is more difficult for you, write the name of that chapter in the comments. And please install our Sapience education application, where we shall upload some important questions the chapter. So thank you everyone.